A warm welcome to all of you in this second lecture on module 3, that is ceramics. If you remember, in module number 1 we have focused on the very basic aspects of ceramics, from where the ceramics word has been derived. We have seen some of the important applications of ceramics, and our focus primarily was to classify the ceramic material into different categories. The ceramics was classified into two broad categories on the basis of the composition of the material and on the basis of the applications. If you remember, on the basis of the applications, we have seen that there are traditional vitreous ceramics, we have seen there are advanced ceramics or for advanced performing ceramics for advanced applications. Then we have seen that there are cement and concrete, there are glasses. So, on the basis of applications there were 4 to 5 categories of the ceramic materials. On the basis of the composition of the material, there were the silicates, then there were oxide ceramics, non-oxide ceramics and the glass ceramics. So, broadly we have classified the ceramic material into two broad categories on the basis of the compositions into silicates, oxide ceramics, non-oxide ceramics and glass ceramics, and on the basis of applications into categories such as glasses, traditional vitreous ceramics, advanced performance ceramics and the cement and concrete. So, broadly we can have different types of ceramic materials. So, we cannot discuss each and every category of the ceramic material, or we cannot discuss the structure or the chemical composition of each category of the ceramic material, as we have seen in the previous lecture that there are wide variety of ceramic materials which are being used. So, our focus would be to limit our discussion to the basic fundamental or the general aspects of the ceramic material, as we have seen in our lecture 1 of this particular module. Now, our focus would be to understand that what is the type of the bonding that exists in case of ceramic materials and how that bonding influences the mechanical properties of the ceramics and how these properties are important for the processing aspects of ceramics, because our focus primarily is to understand the processing routes or processing techniques for ceramics. But before going to the processing techniques, our focus is to understand the fundamental or the basic aspects of the ceramic material, that what are the important properties of the ceramics, because these properties would only help us to understand the various processing techniques of ceramics, and in order to will also help us to find out that what are the specific requirements which have to be met during the processing of ceramic materials. For that we need to understand that what are the specific properties which are relevant in case of ceramic materials. As in case of metals, we have seen that the melting point, the hardness are important properties from the point of view of manufacturing of metals or processing of metals. So, in case of ceramics also we will see the hardness is important property, the melting point is also an important property, ductility is also an important property, whether we can make the ceramic into long wires or not. So, these are the properties related to the materials that we should know before actually processing the material. So, for that purpose and with that thing in our mind, with that we can say introduction required for the processing of ceramic materials, we are undertaking or we are discussing these important fundamental or basic aspects of ceramic materials. So, before going towards the types of bonding available or the types of bonding that is found in case of ceramics and how this bonding affects, which properties are affected and what are the important properties of the ceramic materials, before going into that, let us just have a brief overview of the ceramics which we have covered in the last class. Advanced ceramics are developed for electronics, aerospace and bio applications. So, in the previous class we have seen that there is a we can say specific application spectrum for ceramic materials, and new materials are being developed for new applications. So ceramics which traditionally were used for pottery and clay products only, these days are finding applications in aerospace, electronics and as bioceramics. So why the application spectrum has increased manifold for the ceramics? It is because of some of the important properties that the ceramics possess, such as they are corrosion resistant, they are wear resistance, and they have high hardness. So these are some of the properties. They have low density, means lightweight applications can be there for ceramics. So because of these important properties that the ceramics possess, the application spectrum of ceramics has increased manifold in the past few decades, and this is just to highlight the application spectrum of ceramic materials. The point number 1 gives us an idea that where the ceramics are being used. So on your screen you can just have a look that ceramics are being used for electronics industry, in aerospace applications, as well as in space shuttle applications, as well as they are used as bioceramics in biomedical implants or dental implants, or sometimes in case of synthetic bones also. So the variety of applications of ceramic materials is increasing. Point number 2, traditional silicates, oxide, non-oxides are used for conventional and advanced applications. So this highlights the categorization or the classification of the ceramics which we have covered in lecture number 1, that on the basis of the composition, the ceramics can be classified into 4 broad categories. That is, first one is the ceramic, first one are the silicates, second are the oxides, non-oxide ceramics, and finally the glass ceramics. So these type of materials or these types of ceramics can be used for both conventional applications as well as unconventional applications. And in lecture number 1 we have seen the applications of silicates, we have seen the applications of oxide, non-oxide as well as of glass ceramics. Now the important point, that is the, we can say, some part or of today's lecture we would be focusing on the third aspect that is there on the screen, the properties of the materials. Properties means the mechanical properties, the physical properties, the chemical properties. So the properties of the materials depend upon the types of the atoms present. That is one important criteria which would dictate the properties of a material. The properties of the material will depend upon, that is, first criteria is the types of the atoms present. Second, the types of bonding between the atoms, and third, the way the atoms are packed together. So basically these important, we can say, points will justify or would dictate the properties of a particular material, and those properties would further be used for the processing of that particular material. So the properties are dependent on a number of parameters that are there on your screen, and these parameters would further dictate the properties or would be responsible for a specific set of properties for a specific material, and those properties would be further used. For example, hardness, electrical conductivity, thermal conductivity, toughness. So all these properties may be in a way, one way or the other, related to these important points that have been highlighted on your screen. So the types of atoms present, the packing as well as the bonding, so all these would dictate the properties. Now what are the properties that are being dictated by these, that we would be seeing in the subsequent slide. So the major purpose of this particular slide was to just have a revision of what we have covered in our lecture 1 and to introduce that what we are going to study today. Now most of the ceramics are composed of 2 or more elements. For example, alumina, we have aluminium and oxygen. So most of the ceramics are composed of 2 or more elements, and therefore the structure of ceramics is quite complex as compared to that of metals. So therefore the second point is written, already highlighted, I have already told, the crystal structure of ceramics is relatively more complex as compared to that of metals because of the presence of 2 or more elements in the ceramic. Crystal structures of ceramics are varied, which leads to a very wide range of properties. So the properties that we can expect from a wide variety of ceramics are comparatively different. So a large versatility or a large variety of properties can be achieved with ceramics. Why? Because the crystal structures are quite different. The crystal structures of ceramics are varied. So we can have different types of crystal structures in case of different types of ceramics, and the properties attainable or achievable for a specific class of ceramic would be different. Now bonding in ceramics, that is one of the important points that we want to highlight today. So the bonding in ceramics is two types of bondings usually exist, that is the ionic and the covalent bonding. So the two most common chemical bonds for ceramic materials are covalent and ionic bonds. So the bonding of atoms together is much stronger in covalent ionic bonding than in the metallic bonding. So third point is really important. Point number 1 and 2 highlight that there are two types of bonding, that is ionic and covalent or a combination of both, but it is stronger than the metallic bonding. So we can see that when we have ionic and covalent bond, we have strong bonding in case of ceramics, therefore we cannot plastically deform the ceramic materials, whereas the metallic bonding is weaker as compared to the ionic and the covalent bonding, and therefore in case of metals we can plastically deform them to give them desired shape. So depending upon the nature of the bonding, the type of manufacturing processes that can be applied to a particular material would be different. So the type of processing techniques that would be applied for processing a particular material is quite dependent upon the type of bonding that is existing in the material. So metallic bonding is weaker than the ionic and the covalent bonding. Ceramics have the ionic and the covalent bonding, and therefore they are brittle in nature, they cannot be plastically deformed. There exists a combination of strong ionic and covalent bonds in the ceramics, which has already been highlighted, and it has been related to the processing aspects also. So the strength of the ionic bond depends upon the charge on each ion and the radius of each ion. So these are the two important parameters that would dictate the strength of the ionic bond, and the type of bonding significantly affects the properties of the material. So which I have already highlighted that the type of bonding would significantly affect the properties of the material. Now one important we can say aspect we have already seen, that is it is easier to deform the metals, whereas it is very difficult or we can say nearly impossible to deform a ceramic material. So ceramic will undergo a brittle fracture, whereas the metals can plastically deform. Now why that is possible? That is possible because of the basic nature of the bonding that is there or that is present in the metal as well as that is present in the ceramic. Now depending upon the bonding, as we have already seen, metals have metallic bonding, and in case of ceramics we have a ionic or a covalent bonding. So depending upon the bonding we will have different types of properties. So the type of bonding would significantly affect the properties of the material. Now what are the properties that would be affected? Let us see. Type of bonding in ceramic leads to different types of properties. It would lead to, this is now specifically related to ceramics, but the type of bonding that is there in the material would lead to a certain set of properties for that particular material. So the important point to highlight in the previous slide was that the type of bonding would significantly affect the properties of any material. If we take a metal, in case of metals also the type of bonding would affect its properties. In case of polymer also the nature of bonding would affect the properties. In case of ceramic also the nature and type of bonding would affect the properties. So any type of material, the bonding would affect the properties of the material. So in case of specifically, now let us come to the ceramics. Now specifically in case of ceramics we can see that these are the properties which are being affected by the bonding. So the type of bonding in ceramic leads to, we can say it leads to high melting point, low thermal expansion, high elastic modulus, high hardness, good chemical resistance, and it also makes the ceramics brittle. So we can see There are many properties which are quite useful, and there are many properties which would be causing us a problem when we would try to process the ceramic material into a product. So, you can see high melting point, that is one important property. So, it is very difficult to process materials which have very high melting points, because we need to melt them in many cases to give them a desired shape, or they have to be processed in the solid form only without melting. So, this particular property, high melting point, is advantageous from the application point of view. We have seen that ceramics can be used for high temperature applications, or they have a niche market for high temperature applications, and most of the ceramic products, specifically the refractories, are used for high temperature application, and in that case, or in those applications, the high melting point of ceramics is very advantageous. But in case of the processing aspects, sometimes this may cause a little bit of a problem also. So, high melting point is because of the bonding that exists in the ceramics. Low thermal expansion can be advantageous in many cases. High elastic modulus also advantageous in many cases. High hardness, as we have already seen in our previous lecture, that the ceramic materials are used for wear resistance. So, there the hardness comes into picture. So, high hardness is also a, we can say, after effect of the type of bonding that exists in the ceramic material. Good chemical resistance, and finally the brittle. So, because the ceramic materials are brittle, therefore, in many applications they are discarded. For example, we take an component for engine application. In engine application, all of us know the temperature would be very high. So, for a specific engine assembly component, the temperature would be high. Very first point on your screen, you can see that ceramics have high melting point. So, for high temperature application, we can very easily advocate the use of this ceramic material. Sometimes some oil etc. may be there that is coming in contact with this component, so corrosion may take place. In case of ceramics, we have good chemical resistance, good corrosion resistance. So, that also is satisfied. So, we have a material which is good at high temperature, which has a very high melting point, which can be used for elevated temperature applications. It has good corrosion resistance. There is a, we can say, movement of the material, or it is rubbing against a moving material, wear is there. This particular material has good wear resistance also, that is, ceramics have good wear resistance, they have good chemical or corrosion resistance, they have high temperature application capability, but because of the brittle nature, the application is discarded. Therefore, nowadays there is a focus on improving on this important aspect of ceramic materials, and in our module 6 we will see the ceramic matrix composites, in which this particular aspect, brittleness or the fracture toughness aspect of the ceramics has been addressed properly. So, there we will see that monolithic ceramics are reinforced with the reinforcing phase. The reinforcing phase can be in terms of continuous fibers, or it can be in terms of particulates which are added into the ceramic in order to improve certain characteristics of the ceramic material. So, I have taken an example to just explain that all other criteria is being met. High temperature application criteria is met, wear resistance criteria is met, corrosion resistant criteria is met, chemical inertness criteria is met, but the mechanical load that is coming on the component may be a kind of a impact load, and ceramic material is not so advisable in case of impact loads because of the brittle nature of the ceramic material. So, apart from satisfying all the criteria, because of only one limitation, the application of ceramic for that particular application could not be materialized or could not be finally found feasible. So the problem area has to be addressed, and all these properties, from where they are coming? They are coming from the very basic bonding mechanism or very basic type of bonding that is found in case of most of the ceramics. So bonding is one of the important point that has to be taken care of, and bonding that is existing, it is already existing, so we cannot modify the, we can say, bonding in most of the cases. So already whatever materials are available, whatever bonding is there, it is already there, properties are already known to us. Now these properties we have to take care when we are going to process the ceramic into a desired shape. So before addressing the processing aspects of ceramics, we should try to understand that what are the important properties of the ceramic materials. And now on your screen you can see some of the important properties of the ceramic materials, and these properties we will further see in today's lecture. Also we will see a comparison between the metals and the ceramics, because from the processing aspect of view, we have to, from the processing point of view, we have to see that which are the important processing techniques which are well established for metals, but specifically in case of ceramics, can we apply those techniques? And then we will see that what can be the specific techniques or dedicated mechanisms or dedicated techniques for processing of ceramics. So till now we have seen a brief review of what we have covered in the previous discussion, and today we have seen that there is ionic and covalent bonding that is present in most of the ceramic materials, and these type of bonds are stronger than the metallic bonds, and because of this type of bonding present in the ceramics, these are the mechanical properties or physical and thermal properties which are highlighted on your screen, that these are the properties that are present in the most of the ceramic materials. And now these properties would be used by the engineers to design and develop the processing techniques for ceramics. Again coming to the same diagram which we have seen in lecture 1 also, let us now see this diagram from the processing point of view. Now density of ceramics is less, for metals it is high, hardness for ceramics is high. So we cannot think of machining the ceramic material, because diamond is also a kind of a ceramic, so difficult to machine the hardest substance known. So basically hardness is an important criteria which has to be taken care of. So metals have low hardness as compared to the ceramics, and therefore they can be processed easily. One metal can be used to cut another metal. Only condition is the hardness of the cutting tool should be greater than the hardness of the workpiece material. So metals can be machined, but machining of ceramics is a bit difficult because of the very high hardness of the ceramic materials. Coming on to the ductility. Now ductility is an important property of the material which makes it amenable to be drawn into long wires. So ceramics cannot be drawn into long wires because the ductility of ceramics is low, whereas metals have a very high ductility and therefore they can be drawn into thin wire. All of us have seen the wires made up of metals. So ductility is an important criteria which is low for ceramics. So therefore if we want to make a wire of a ceramic material, we have to think of the process which can be used for making a wire of ceramic material because of the low ductility of the ceramic material. Similarly, we can see electrical conductivity of ceramics is low, whereas in case of metals it is high. We have many unconventional manufacturing or processing techniques, like most of the engineers know about the electro discharge machining, EDM process. Now for a material which has no electrical conductivity, it is difficult to process by electric discharge machining, whereas metals have high electrical conductivity, they can be easily processed by the electrical discharge machining process. So all these properties on your screen is one way or the other way related to the processing of the materials. So whatever property is there, it will have the direct bearing or the indirect bearing on the processing of that particular material or for a processing of a particular material. So, we can see hardness, ductility, density, thermal conductivity, electrical conductivity, all these properties will have effect on the processing of the materials. So, we have seen that it is difficult to make wires of the ceramics, it is difficult to process ceramics where the high conductivity is desired in the workpiece material because the electrical conductivity is low for ceramics. It is difficult to melt the ceramics also because the melting point of the ceramics is also very high. So, these properties we have to understand before subjecting the ceramic material to be converted into a particular product or before subjecting a ceramic material to any of the processing techniques. So, here we have just tried to understand the same diagram, but from a slightly different perspective, that is from the point of view of the processing aspects of the materials, and the materials we have compared are the metals and the ceramics. Now, what are the various types of ceramic materials? Let us see. Although we have classified the ceramics, but now we want to see the different types of ceramic materials that are available. Oxide ceramics like alumina, zirconia, carbides like silicon carbide, tungsten carbide. Now, silicon carbide, let me give you an example, is being used as a reinforcing material in many metal matrices. As we will see in our subsequent classes, there is a new class of materials which has been developed some 2-3 decades back, that is the composite materials, and composite materials have been designed and developed in order to meet some specific design requirements of many applications where single material cannot meet the demand. So, basically two macro constituents have to be combined together to make a third material which has the best properties of material 1 and material 2. So, we are combining the two materials and making a third material. Third material has the properties of both, but possess certain special characteristics or special properties which are not achievable by any one of these taken alone. So, those composite materials we are going to study, specifically the polymer matrix composites and the ceramic matrix composites, and silicon carbide is used as one of the reinforcing materials in case of metal matrix composites, in which the matrix is a metal and the reinforcement is ceramic, that is silicon carbide. So, and we get a material which is having very good hardness, which is having good wear resistance, and which is used for many engineering applications. So, silicon carbide can be used as a reinforcement material in the metallic matrix. Next are the nitrides, the cubic boron nitride, the titanium nitride. So, we can see cubic boron nitride, CBN most commonly used. It is a very high hardness material which is used as a tool material in many cases or a coating on the tool, and it has got high hardness that I have already told, and has got good, we can say, temperature resistance, that is at elevated temperature when the tool is in contact with the workpiece, it will hold its mechanical properties. So, cubic boron nitride is a material which is being used in cutting tool applications. Then there is titanium nitride which is used as a coating material on the cutting tool and has got good frictional properties or good frictional characteristics. So, nitrides is another class of ceramic materials, carbide is another class of ceramic materials, oxide ceramics examples are there, alumina or zirconia. Alumina, yes, is also used as a reinforcing material in the metal matrix composites. Then we have cermets. Cermets basically are the combinations of the ceramics and the metals. So, metals provide the toughness and the ceramics provide the distinct characteristics of high temperature application, good wear resistance, and we have seen a number of good properties or usable properties of the ceramics. So, ceramics and metals are combined together and they are taking advantage of the best properties of the two and coming in the form of a third material which possesses the special characteristics of the ceramics as well as the important characteristics of the metal. So, cermet is another category in which we have the ceramic material. Then glass ceramics, we have seen that basically glass ceramics possess a special advantage that they have combined the easy processability of the glass with the distinct characteristics of the ceramics. So, glass ceramic is another type of ceramic which is being used. It has an enhanced toughness, it has good strength, and sometimes it can be made superconductive also. So, glass ceramics have got their own characteristics. Then we have the hardest substance known, that is diamond. So, diamond is also used as a cutting tool. It can exist as PCD, that is polycrystalline diamond. Diamond grit is sometimes coated on the cutting tool in order to improve the hardness of the cutting tool. So, basically types of ceramics, the important point of highlighting this particular slide is to give a application spectrum of the ceramics and to give or revise the classification of the ceramics, that we have oxide ceramics. In case of non-oxides, we have carbides and nitrides. Then we have a special combination of metals and ceramics, that is cermets. Then we have a combination of glasses and ceramics, that is glass ceramics, and finally we have diamond, which is the hardest substance known. So, there can be different types, and this list is not an exhaustive list of the types of ceramics. There can be other additions also in this list, but this is just to give you an overview that what are the different types of ceramic materials which we are using in our day to day life. Now, this is we can say a very busy slide. So, in this busy slide we can see at the center we have the properties of the ceramic materials. So, this is just giving a summary before jumping on to the processing aspects of ceramics. Now, this is a summary of, we can say, the properties that are present in case of ceramics. It is not only the advantage or the disadvantage, but the properties that the ceramics possess. So, we can see properties of the ceramics. Let us start from here. They are hard, that is they have high hardness. Brittle in nature, this we will try to understand with the help of a stress strain diagram, in which we will see that how the brittle fracture takes place in case of ceramics. Refractory means they can be used for high temperature applications like linings in the kilns, or they can be used for crucible applications. So, there can be different refractory applications. So, important point is that most of the ceramics are used for high temperature applications. They are prone to thermal shock. So, that is another, we can say, property maybe that has to be taken care of in case of some of the ceramics. Chemically they are stable, that is they are we can say corrosion resistant. They are not prone to chemical attack, means they are we can say chemical resistance is good, corrosion resistance is good. So, they are chemically stable. Oxidation resistant. So, oxidation of ceramics is we can say not an easy task. Non-magnetic in nature. Electrical insulators. In many electrical engineering applications we see ceramics being used as electrical insulators. Then they are also sometimes used as thermal insulators also, because they have poor thermal conductivity, poor electrical conductivity. Then they are wear resistant. These two properties are, we can say, related to one another. They are wear resistant. So, we can see that many properties are there for ceramics. So, they are a versatile materials and they possess a wide variety of properties, and some of these properties may make them amenable to processing, and some of these properties may act as an hindrance for the processing of ceramics. So, these are the properties which give rise to a large number of applications for the ceramic materials. So, we can foresee a large number of applications for ceramic because they possess so many diverse properties. So, just to have a revision of the properties that the ceramics possess, let us just revise that they are hard, brittle, wear resistant, thermally they are insulators, electrically they are insulators, non-magnetic, chemically stable, refractory properties are there, oxidation resistant, thermal shock. So basically a wide variety of properties are there for the ceramic materials, and we can see out of these, if we say let us choose 4 important properties and try to find out the applications of based on those 4 properties. Let us take the example of hardness. They are hard, therefore they are used for watch making. In watches sometimes they are used for making the cases, scratch free or scratch resistant cases in case of watches. So that is one important property, that is hardness. Then on the basis of, we can say, electrical insulator, because they have electrical insulation property, they are poor conductors of electricity, therefore they can be used as electrical insulators for electrical engineering applications. They are chemically stable, so they can be used for making the laboratory crucibles or laboratory equipment, because they will not react with the chemicals that are being used in the laboratory. Then we can say refractory is another property of the ceramic material. On the basis of refractoriness, they can be used for brick linings, or they can be used for in the, we can say, furnace as a covering material. They can be used for high temperature applications, for example in space shuttle such as ceramic tiles. So high temperature applications, refractory properties, scratch resistant applications, hardness, insulation, thermal and electrical, large number of applications are there, wear resistance applications are there. So we can see that ceramic materials possess a wide variety of properties, and these particular properties make them very upcoming, or we can say a very promising engineering materials. But there are few limitations, such as the brittle behavior or the fracture toughness. So fracture toughness and brittle nature of the, we can say, ceramics have to be addressed if we want to further increase the application spectrum of ceramic materials. Now coming on to the strength of ceramics. Let us see, this is just the strength is a very, we can say, common word which has been highlighted here. So strength can be tensile strength, compressive strength, shear strength. So let us see, we can say the strength of ceramics basically is dependent on, smaller the particle size, the higher is the strength of the ceramic. So different particles make up the ceramic, because we will see powder processing technique for processing of ceramics. There we will see how we will blend the powders together to make a ceramic product. So basically there we will address the size of the particle would affect the properties or the mechanical properties of the ceramic product. So when we will make the ceramic from the powders, the properties of the powder would affect the mechanical properties of the ceramic product. Dense microstructure enhances strength. Yes, the porosity is less, we will get better mechanical properties. And increased toughness leads to enhancement in resistance to fracture. So basically we want resistance to fracture, we want good fracture toughness. So an increased toughness would help us to improve the fracture toughness aspect of the ceramics. High particle aspect ratio may be useful in enhancing the toughness. So basically the materials that we are using, that is the particles that we are using for making a ceramic product, would affect the properties of the final product. So two important points are highlighting that aspect, that is the size, that is point number 1, and the aspect ratio, that is point number 4. So these two important points would be discussed when we will see the powder processing technique of ceramic fabrication or ceramic product fabrication. So now let us see, try to understand an important aspect of ceramics, that is the stress strain behavior of the ceramic products or the ceramic materials. So on your screen you can see that if we plot a stress strain curve, for a ceramic material it will be something like this, and then the load would come down, that is brittle fracture would take place. Whereas in case of metals we will see that when we are loading it under tensile load, we will see that necking will take place, and finally we will get a different type of a stress strain curve. I think this is a very common stress strain curve for metals which is taught in almost all the engineering colleges and engineering curriculum. So, that we are not, I am not going to draw here that what is the stress strain curve for a metal, but I think everybody should be able to distinguish the stress strain curve between a metal and a ceramic. So, in case of ceramic we can see that there is no elongation taking place, there is a brittle fracture that is taking place, and similarly the tensile and compressive behavior of ceramic would also be different. Under tensile load we will see that the ceramics would fail at a fairly less stress levels, whereas in compressive kind of loading the ceramics can take more load to failure as compared to the tensile loading condition. So, basically we can see the stress strain behavior of ceramics is different from the stress strain behavior of metals, and therefore the processing techniques that we can use for processing of ceramics should be different from the techniques that are used for processing of metals. Now, coming back to our discussion, we have seen that the mechanical properties of ceramic are different from the mechanical properties of the metals, and therefore the processing techniques for ceramics would be different from the processing techniques that we have developed for metals. So, we have tried to understand the stress strain behavior also, that the brittle fracture takes place in case of ceramics, whereas necking takes place in case of metals, and finally the failure takes place. So, because of the difference in the mechanical properties of the two materials, that is the ceramics and the metal, the processing techniques that would be used for processing of ceramic and for processing of metals would also be entirely different. So, that is an important point to note, because whatever processing techniques we would be seeing in the subsequent lectures would be different from the techniques that are used for metals. Now, coming on to the electrical properties of ceramics, the last slide just highlighted that the mechanical properties of ceramics are different from the mechanical properties of metal, and one important aspect that has just come to my mind is that one of the applications of ceramics is, if you remember in our previous lecture, that is lecture number 1, we have classified the ceramic materials into two broad categories or two broad classifications. That is, one was based on the nature of the composition of material, that is based on the composition of the different types of ceramics, and a second one was based on the application of different types of ceramics. So, in the application side, if you remember, we have seen that cement and concrete is also a ceramic material, and if you remember, if you have this information with you, that concrete is very good in compression, but is very poor in tension. Similarly, we are seeing a general behavior of the ceramics that when we apply compressive load, they are able to take more load to failure, whereas in case of tensile loading, the failure stresses are less or the failure load is less. So, under tensile application, ceramics should not be advocated, or the use of ceramics should not be advocated where the tensile loads are going to come on the component, but certainly in comparison to the tensile loading, they are able to sustain a higher compressive loading. So, here we can draw one-to-one analogy between a typical ceramic and a concrete, which is also a type of a ceramic. So, we have seen in our applications that cement and concrete are also with the types of ceramics based on the application point of view. Now leaving the mechanical aspects, now coming on to the electrical properties of ceramics, we can see on your screen electrical conductivity of most of the ceramics is low, and therefore they are used for electrical insulators for electrical insulation. So the electrical conductivity of most of the ceramics is low, and therefore they are used for electrical insulation purposes. Electrical conductivity depends on the applied field, which is common. Depending upon the applied field, the conductivity would be it is dependent on the applied field. Some ceramics show, now this is an important point, some ceramics show semiconducting properties. So we have seen that there is a wide variety of ceramics, one or two elements combined together to make a single ceramic material, and there are large families of ceramic materials, as we have seen when we have seen in lecture 1 the classification based on the composition. We have seen silicates, non-oxides, oxides and glass ceramics. Within each we have a large number of further categories of ceramics. So some of the ceramics show the semiconducting properties, and ceramics also show temperature dependent superconducting properties also. So in general we can say that the electrical conductivity of most of the ceramics is low, and therefore they are used for electrical insulation purposes, but some of the ceramics do possess semiconducting or the superconducting properties at elevated temperature, and one of the points that is highlighted here is that the conductivity will depend upon the applied field. So with this we come to the end of lecture number 2 in module 6, but before leaving the lecture we will just see or just revise the applications of ceramics, so that as an audience you have in your mind that whatever or what are the important or typical applications of ceramics, so that whenever you see any ceramic application around, you just have an idea that this is a ceramic product, this might be having this type of bonding, this particular product might be having this type of properties, as we have seen that it is good wear resistance property, good we can say thermal insulation property, good electrical insulation property. So it may be having high melting point. So just by looking at a ceramic product, you can have an idea that these are the properties that this particular product should possess. So just before leaving the lecture, let us just end the lecture with these typical applications. On your screen you can see pottery, floor and roof tiles, because all of us see floor and roof tiles, bricks, cookware, sanitary ware. So these are some of the ceramic applications, starting from our household applications, then high temperature applications such as lining, crucibles. So lining basically is a lining material in the furnaces. We can have crucibles as high temperature or refractory applications of ceramics, and then we have we can say high performance applications of ceramics, that is bulletproof armor, hard coatings on some metallic materials, biomedical implants, ball bearings, and as I have already discussed in today's lecture only, the watch making, the cases of the watch can be made scratch resistant with the help of ceramic materials. So this is just the applications all around us, and looking at these applications we can have frame in our mind that yes, this is a ceramic material, and this particular product should be possessing these type of properties. So that was the basic idea of having these two lectures on that is ceramics 1 and ceramics 2. And with this brief overview about the ceramics, now we would start our discussion in the subsequent lecture on the processing techniques of ceramics. Thank you.